Section 1.7 Exponents and the order of operations. Two students were given the problem 6 plus 4 times 3 and asked to solve it. The first student said, well, I'm just going to say 6 plus 4 is equal to 10, and then 10 times 3 gives me 30 for an answer. The second student, once again having the same problem, said, I'm not going to do it that way. Instead, I'm going to say 4 times 3 is 12, and then 6 plus 12 equals 18. Which student is correct? Well, in math, there's only one correct answer. And the correct answer has to do with something called the order of operations, more commonly known to many people as, please excuse my dear Aunt Sally. Let's explore that idea a little bit. Just like having rules when driving, for instance, a red light means to stop, mathematicians have developed a list of rules to use when performing computations on a string of numbers. One of the rules says, always do the multiplication or division before doing any of the addition or subtraction. So, the correct answer to 6 plus 4 times 3 is 18, not 30, because a mathematician would do the 4 times 3 first. But one of the biggest mistakes people make sometimes is realizing what to do when there's just multiplication and division, or just addition and subtraction. Let me give you an example. If you were to have the problem 10 subtract 7 plus 3, all I have in this problem is addition and subtraction. If all you have is addition and subtraction, the rule is to go in order from left to right. So I would not do the addition first. I would do the subtraction first in this particular case. So I would do the 10 subtract 7. 10 subtract 7 is equal to 3. And then 3 plus 3 gives me 6 for my final answer. If I was given the problem 20 divided by 4 times 5, once again, all I have is multiplication division in this problem. And if all I have is multiplication division, I'm just going to go in order from left to right. So I would do 20 divided by 4 first. 20 divided by 4 is 5. Then I have 5 times 5, and I get 25 for an answer. You see this kind of mistake a lot on problems when people are doing just addition, subtraction, or just multiplication and division. Please be careful with this. So let's go through and do a problem that has all 4 of the operations. And I'm going to do this problem in a particular way. What I do is I solve one of the computations at a time and then copy everything else down. So I have 10 subtract 8 divided by 2 plus 6 times 5. I have to do all the multiplication division first, and I have both division and multiplication. But since division comes first, I am going to do the division operation first. So I'm going to circle that, 8 divided by 2, and then what I'm going to do is I'm going to copy everything that I have. I have 10 subtract. Now 8 divided by 2 that I'm going to do first is 4 plus 6 times 5. Next, I'm going to go through and I'm going to do the multiplication that I have. So I'm going to circle 6 times 5. And then when I recopy, I have 10 subtract 4 plus 30. Now I need to do the subtraction. All I have is addition and subtraction. I am going to do the subtraction because it comes first. 10 subtract 4 is equal to 6. 6 plus 30. And then my final answer is 36. I have found this method of students going through and circling just one operation at a time and then recopying everything down to the next level really works for many students. But there are other rules to follow also. The first rule is operations in parentheses are always done first, regardless of what the operation is. Remember earlier we had done the problem 20 divided by 4 times 5. And I had said for that particular problem you would do the division first because it comes first and all you have is multiplication and division. So for this particular problem, as we talked about before, I would do the 20 divided by 4 is equal to 5, and then 5 times 5 gives me 25 for my final answer. But if the problem instead was written 20 divided by, and then in parentheses 4 times 5, parentheses means do me first. So I would, first of all, do what's inside the set of parentheses, which is 4 times 5. So I would have 20 divided by 20, and in that case the answer is 1. The very first rule with order of operation is anything that's in parentheses needs to be done first. There's one other rule that also comes before multiplication, division, addition, subtraction, and that is the rule of exponents. Exponents is repeated multiplication of the same base. So if you have something like 2 and a little 3 to the upper right of that number, that 3 is known as the exponent, while the 2 is known as the base. It's oftentimes said something like 2 to the third power. 2 to the third power means that you are going to multiply the base by itself 3 times. So 2 to the third power means 2 times 2 times 2. 2 times 2 is 4. And then 4 times 2 is 8. So 2 to the third power is equal to 8. Another example, if you have 4 to the second power. 4 to the second power means that you're going to take the base 4 and multiply it by itself twice. So it means 4 times 4, which is equal to 16. Another common way of saying 4 to the second power is 4 squared. So you might hear that as well. Whenever the exponent is a 2, you might say squared instead. One more example, 5 to the third power. 5 to the third power means 5 times 5 times 5. 5 times 5 gives me 25, times another 5 gives me 125. And one other thing to note, just like if you have an exponent of 2, we say squared. If you have an exponent of 3, sometimes people, instead of saying to the third power, they will say cubed. So make sure that you remember squared means to the second power, cubed means to the third power. One other important thing to remember when exponents is that any number other than 0 raised to the 0 power is equal to 1. So if you have something like 2 to the 0 power, 2 to the 0 power is equal to 1. 16 to the 0 power is equal to 1. 4 to the 0 power is equal to 1. Let's take a look at why this is. I'm going to set up a series of problems here that we're going to go through and solve. 2 to the fourth power, as we said, means 2 times 2 times 2 times 2, which if you multiply all those, you get 16 for an answer. 2 to the third power means 2 times 2 times 2, which is equal to 8. 2 to the second power means 2 times 2, which is equal to 4. 2 to the first power just means you have 2. So it's just equal to 2. Take a look at what we are doing here. We actually have a pattern. What we're doing is we are reducing the exponent by 1 every time. And when we do that, the answer is divided by 2 every time. So if we continue that same pattern, and I say 2 to the 0 power, I'm going to reduce that, I'm going to have to do exactly the same thing. I'm going to have to take that answer, I'm going to have to divide it by 2. 2 divided by 2 gives me an answer of 1. So 2 to the 0 power has to be equal to 1. We could look at this with one other example as well. If I have 5 to the third power, 5 to the third power means 5 times 5 times 5, which is 125. 5 to the second power means 5 times 5, which is 25. 5 to the first power is just equal to 5. So if I have 5 to the 0 power, once again I'm just reducing the exponent by 1, well, what happened to the answer every time? Well, I divided by the base, in this case, 5. So I'm going to have to do the same thing. 5 divided by 5 gives me an answer of 1. Remember, anything to the 0 power other than 0 is equal to 1. So, the way many people remember the rules for order of operations is to think of, please excuse my dear Aunt Sally. The P in please stands for the parentheses. Always do anything inside the parentheses first. The E stands for exponents. Next, you're always going to do anything with exponents. The my dear stands for multiplication division. But remember, whatever comes first in the string of numbers is what you're going to do first. You're not necessarily going to do the multiplication before the division. It's whatever comes first. And the Aunt Sally stands for addition, subtraction. And once again, the same. You're going to do whichever of those two operations comes first in that string of numbers. So let's go through and do a problem here. I'm going to write out a problem. This is actually problem number 31 from the book that we are currently using. And it is a long problem. And as I go through and do this particular problem, I am going to be following the rules that are up above as we go through and do this. One thing I do want to mention, when you are doing the homework in the book, sometimes you will see, in place of a multiplication sign, you will see a dot. So if you see something like 5.3, that dot means the same thing as 5 times 3. It's just a notation. So 5.3 is 5 times 3, which is 15. I have not written it this way on that problem, although the multiplication signs on the problem are written that way. So if I'm going to go through and do this particular problem, first of all I have to do whatever is inside the set parentheses. So I'm going to circle, and I have 16 minus 12 inside the set parentheses, and then I'm going to go through and I'm just going to recopy everything that I have, and I'm going to solve whatever I circled. So 16 minus 12 is equal to 4, and I put that down there. Next I have to do whatever is exponents, because I don't have any parentheses left. So I'm going to do 4 to the second power, and then I'm going to recopy what I have. 4 to the second power means 4 times 4, which is 16. So the ending of that is 16 times 3. Now I have to do the multiplication division, whatever comes first. And I have 12 divided by 3. So I'm going to circle that and then recopy. 12 divided by 3 is 4. And now, the next step, once again, I have just multiplication in there. So I'm going to do the very first multiplication that comes first. So now I have 16 subtract 8 plus 16 times 3. Now I have subtraction, addition, multiplication. I'm going to do the multiplication first, the 16 times 3, and recopy. I have 16 subtract 8 plus 16 times 3 is 48. And now all I have left is addition, subtraction. I'm going to do whatever comes first, which is 16 subtract 8. 16 subtract 8 is equal to 8. So I have 8 plus 48, giving me a final answer of 56 for that problem. Knowing the rules for order of operations is extremely important when doing math, especially when doing algebra in later courses. If there is anything I can do to assist in your understanding, please let me know.